Welcome to my thesis presentation of an RSA-based secure image stenography technique using adaptive data hiding. Myself, F. Makash Char. My thesis supervisor is MD Maruf Hassan. Let's begin. Background study. Today's global internet download speed is huge. The average global download speed is about 83 Mbps, and it is so higher than the previous decades. So then we can see the internet users are growing from the previous years. The growing rate is also significant. We can also notice the e-commerce sales, then use of learning websites, and the digital payments are growing. That's because of the digitalization. But with the digitalization, it comes with some disadvantage also. We are facing cyber attacks in recent years. We can see some data breaches history. We can see in every country the data breaches amount is growing. In recent years, Bangladesh also faced some data breaches. So it is become a very important issue. So we have to be more careful in data security. We know there are various mechanisms of data security. Those are cryptography, watermarking, stenography, and all of these have different purposes such as data encryption, ownership proof, and data concealment. In stenography, we talk about data concealment in a way that a naked eye cannot identify. In stenography, we hide information within an object that does not identify by a naked eye. We know stenography has fundamental principles, some fundamental principles. Those are imperceptibility, capacity, and robustness. These are important factors to work stenography. In our thesis, we have choose image as a cover object. That's because it has widespread use, it has many complexities in it, and image has a large amount of redundant information in it. So we can use this object in digital platform without getting identified. Application of our proposed solution, we can secure our communication, we can hide data, and we can ensure image quality with high impressibility. Research gap. Current stenographic method is insufficient in embedding capacity, security, and image quality, and there are not enough robust stenography methods also. We identified some problem statements from the issues. There are lack of higher embedding capacity, lack of good stego image quality. The current methodologies face challenges when exposed to diverse attacks. So we found out the problem statement in existing methodologies have limitation in terms of embedding capacity while preserving the quality of stego image. Existing methodologies encountered challenges when confronted with various type of attacks, posing a potential risk of data exposure. Research gap we have found, research objective we have identified is to enhance embedding capacity without degrading the image quality, to improve security aspect that can effectively protect the hidden data against different type of attacks. This is a sample of literature review where you can see some authors and their used techniques and some results of the studies. We can see in 2005 a method has been proposed by W. et al. Using the PVD and LSB method, and he got a good amount of PSNR value, but the security was less. And then in 2000, Young et al. Proposed another method. There we got a good amount of PSNR with a good amount of capacity. Next, in 2012 and 2018, we see the capacity is growing and PSNR is also growing and the security are getting high. In this methodology, we can see how stenography works. A secret message and a cover image and a stego key go to the embedding algorithm, and the embedding algorithm produce a stego image. And then the stego image passes through the communication channel from sender to receiver, and then the receiver put the stego image in extraction algorithm and get a secret message with the cover image. But the receiver need the stego key to do that. In this flowchart, we can see we have used RSA as the encryption technique and PVD and LSB for the embedding technique. And by this process, we can get our stego image. Why did we use RSA? Because RSA is a asymmetric encryption which guarantees secure and confidential data hiding. Why LSB? Because when we implement data hiding in LSB, it does not lower the visual quality. And why PVD? Because the PVD, when we use PVD, we can get a good amount of capacity. These are the quality metrics we might use in our thesis. The most important one is PSNR. There are others quality metrics also. Significance of the study. The use of RSA cryptography helped to ensure the security of the secret message, allowing to verify if message has been altered or not. The combination of LSB and PVD can provide higher capacity while preserving the quality of the stick image. Conclusion: we expect a PSNR score of 40 dB with excellent SSIM, and our proposed approach RSA, LSB, and PVD for a secure messaging. Thank you for watching.